Hi guys, welcome to Unacademy CET YouTube live session. Myself Sharif. In this particular video, we will discuss the MCQs of NCERT Exemplar Differential Equation. And after finishing that, I'm going to discuss MCQs on integral calculus of NCERT. Right, question number 1. The degree of the differential equation when you have sine of dy by dx or cos of dy by dx, degree of a differential equation is defined only if it is a polynomial function and derivative. Sine of dy by dx degree is not defined. Question number 2. The degree of the differential equation is, if you square on both sides, this will cancel. Order is 2, degree is 2. So degree will be equal to 2. Answer is option D. Right now, you call this as equation 1. If I differentiate once, dy by dx is equal to e power minus x. First function is differentiation of a cos x. Differentiation of a cos x is minus a sin x plus differentiation of sin x is cos x. This is first differentiation of second. I'm using u into v product rule. U into v dash plus v into u dash. U dash is equal to v into u dash plus u into v dash. And differentiation of e power minus x is minus e power minus x. Okay, so this is dy by dx is equal to e to the power of minus x into minus a sin x plus b cos x. Right, and then this is minus. This is if I use equation 1, from equation 1, this fellow is same as y. If I differentiate once again, d square y by dx square is equal to e power minus x u into v dash, that is differentiation of sin x is cos x and cos x is minus sin x, u into v dash plus v into u dash. Differentiation of e power minus x is minus e power minus, you call equation 2, the minus e power minus x, and then differentiation of y is dy by dx. This is d square y upon dx square. If I use equation 1, from equation 1, it's the same as minus y. Okay, and this is from equation 2. From equation 2, I'll take minus outside. This minus e power minus x, I'll keep minus as it is. Minus a sin x plus b cos x into e power minus x will be dy by dx plus y. And this is minus dy by dx. Right, now if I open the bracket, d square y upon dx square is equal to minus y minus dy by dx minus y minus dy by dx. If you shift on the left side, this is d square y upon dx square, okay, plus 2 into dy by dx plus 2y is equal to 0. Right, answer is option C. Let's move to the next question. You call equation 1. If I differentiate dy by dx is equal to differentiation of cos alpha is minus alpha sin alpha, right? And differentiation of sin x is cos x, so alpha cos alpha x. If I differentiate once again, d square y by dx square is equal to minus a alpha square, this is cos alpha x, minus b alpha into alpha square into sin alpha x. This is equal to minus alpha square, I take common, left out a cos alpha x plus b sin alpha x. Right, this is from equation 1. From equation 1, this will be equal to minus alpha square y. Shift on the left side, you will get d square y upon dx square plus alpha square y is equal to 0. Right, answer is option B. Let's move to the next question. The solution of the differential equation is, see, I can write this as x into dy is equal to y into dx, right? I can write dy by y is equal to dx by x. Now if I integrate, integration of dy by y is equal to integration of dx by x. Integration of 1 by y is log y, integration of 1 by x is log x, and plus c. I can write this as log of log y minus log x is equal to log c, right? Okay, or here itself I can write log y is equal to log x, and c can be written as log c. Log y is equal to log x plus log c is log cx. Now if I equate the values, y is equal to cx, which is of the form y is equal to mx. Y is equal to cx is of the form y is equal to mx. Y is equal to mx is a line which will straight line passing through the origin. Right? Question number 7. The solution of the differential equation is, right, we'll separate the variables. So tan by into sec square x dx is equal to minus tan x into sec square y dy. Right, now this can be written as sec square x divided by tan x dx is equal to minus sec square y divided by tan by dy. Right, now if I integrate, sec square x divided by tan x dx is equal to minus integration of sec square y tan by dy and then plus c. To differentiate denominator, you get numerator. This is of the form f dash of x divided by f of x, which is equal to log fx. So log of denominator, log of tan x is equal to minus log tan y minus log tan y. C can be written as log c. Shift on the left side, log m plus log n is log m into n. Okay, so this will be equal to log of tan x plus log of tan y. Log of tan y is equal to log c. Log m plus log n is log m into n, right? This can be written as log of tan x into tan y is equal to log c. Log c is same as log k, right? If I equate them, you get tan x into tan y is equal to k. That's the last option, D. Question number 9. Y equal to ax plus ax cube of the curves is represented by the differential equation of what is the degree. You call equation 1. I differentiate dy by dx is equal to a, right? If I substitute back in equation 1, you will get dy by, if I substitute back in equation 1, this becomes y is equal to dy by dx into x plus this is a cube, right? Dy by dx the whole cube. Okay, it's a degree of differential equation 3. Order is 1, degree is 3. Alright, I want the integrating factor. I'm going to divide by x. If I divide throughout by x, dy by dx minus y by x is equal to x power 4 minus 3x and whole divided by x. This is of the form dy by dx plus py is equal to q. Okay, p is equal to minus 1 by x. Integrating factor is e per integration of p dx. E per integration of minus 1 by x dx. E to the power of integration of 1 by x is log x. minus log x can be written as log 1 by x. E power log x is x, you get 1 upon x. Answer is option C. Alright, let's move to the next question. What is the solution of this differential equation? This is of the, see, rather than I do that, I can write dy by dx is equal to 1 plus y, right? Dy by 1 plus y is equal to dx. Now if I integrate this, integration of dy divided by 1 plus y is equal to integration of dx plus c. Right, integration of 1 by x is log x, right? So this is log of 1 plus y is equal to x plus c. Now if I use the boundary values, according to the question, y of 0 is 1, right? Y of 0 is 1 means when x is equal to 0, y is equal to 1. You get log 2 is equal to c. Substitute the value of log 2 in equation c value. This will be equal to log of 1 plus y. Okay, log of 1 plus y is equal to x plus log 2. Now, when you have suppose log x to the base a is equal to m, then x is equal to a power m, right? This can be written as 1 plus y is e power x plus log 2. 1 plus y is equal to e power x into e power log 2. 1 plus y is equal to e power x, e power log 2 is 2 only. Y is equal to 2 e power x minus 1. That's the last option, guys. So 2 e power x minus 1. Question number 12. This was asked in 2022 paper. Dy upon y plus 1 is equal to dx upon x minus 1. Now if I integrate, dy by y plus 1 is equal to integration dx by x minus 1 and plus c. Integration of 1 by x is log x. You get log of 1 plus y is equal to log of x minus 1, and c can be written as log c. So this is log of y plus 1 upon x minus 1 is equal to log c. If I equate the corresponding values, then this can be written as y plus 1 upon x plus 1 is equal to c. Sorry, x minus 1. Y plus 1 by x minus 1 is equal to c. Boundary values are y of 1 equal to 2, right? That is when x is equal to 1, y is equal to 2. For x is equal to 1, it does not define. So I can write x minus 1 by y plus 1 is equal to c1 or 1 by c. 1 by c I'll take k. 1 is equal to, I'll take this as k. Now if I substitute x is equal to 1, y is equal to 2, you get 0 is equal to k. Okay, substitute back here. You will get x minus 1 by y plus 1 is equal to 0. Cross multiply, x minus 1 is equal to 0, x is equal to 1. So there's only one solution. Number of solutions is 1. Okay, let's move to the next question. Tan inverse of x plus tan inverse of y is equal to c, right? Tan inverse of x plus tan inverse of y is equal to c is the general solution of which equation? If I differentiate, differentiation of tan inverse of x is 1 by 1 plus x square. Differentiation of tan inverse of y is 1 by 1 plus y square into dy by dx is equal to 0. 1 by 1 plus y square dy by dx is equal to minus 1 by 1 plus x square. So this can be written as dy by dx is equal to minus of 1 plus y square upon 1 plus x square. This should be 1 plus y square, okay, upon 1 plus x square. Now if I cross multiply, there's no option. This is ruled out. This is ruled out. If I cross multiply 1 plus x square into dy is equal to minus of 1 plus y square into dx. So this is 1 plus x square into dy. That minus you shift here, it will be 1 plus y square into dx. Right, is equal to 0. Answer is option C only. Let's move to the next question. The differential equation represents the curve. I can write y into dy. Y into dy by dx is equal to c minus x. dy divided by c minus x is equal to, right, I'll cross multiply this. We'll separate the variables. Y into dy is equal to c minus x into dx. Now if I integrate this, integration of y into dy is equal to integration of c minus x into dx and plus c, isn't it, guys? Integration of dy is y square by 2, right? Integration of x is x square by 2. Coefficient of x is minus 2, divide by minus, and this is plus c. Now if I multiply by 2, this is y square by 2 is equal to minus, I can write c minus x the whole square as x minus c the whole square by 2, okay, and then plus c. Now if I shift on the left side, it should be a circle, guys. X minus c the whole square by 2 plus y square by 2 is equal to c. If you multiply by 2, you get x minus c the whole square plus y square is equal to 2c. Now this is of the form x minus s the whole square plus y minus k the whole square is equal to r square. It should be a family of circles. Answer is option D. Alright, the general solution of the equation is, if I separate the variables, e power x into cos y, right, into dx is equal to e power x into sin y into dy. Right, if I separate the variables now, I can cancel dx, right? Sorry, e power x, right? This can be written as dx is equal to sin y divided by cos y, and then this is dy. Now if I integrate, integration of dx is equal to integration of tan y dy, okay, and then plus c. Integration of dx is x, integration of tan y is log sec y, log sec y and plus c. It's understood when you write log, it is to the base c. Now there's no option like this. Alright, x minus c is equal to log to the base c of sec y. Okay, now I'll separate the variables. Log to the base y of sec y is equal to x minus c. Then you get sec y is equal to e to the power of x minus c. Now sec y is equal to e power x into e power minus c. I still don't get option like this. C can be written as 1 by cos. Okay, and then that's equal to e power x and then divided by e power c. If I cross multiply, e power c is equal to e power x into cos y. E power x into cos y is equal to e power x cos y is equal to e power c is a constant, k is also a constant, right? Answer is option A. You have to simplify till you so that you bring it to the option form, guys. Answer should be equal to A only. e power x cos y, c is a constant, e power c is a constant, so I take that as k. Right, let's move to the next question. The degree of the differential equation is order is 2, right? Degree is 1. This is linear differential equation. This is of the form dy by dx plus py equal to q, right? P is equal to 1 and q is equal to e power minus x. Integrating factor e power integration of p dx, e power integration of dx, which is equal to e power x. Solution is y into integrating factor is equal to integral q into integrating factor and then dx plus c. Y into if is e power x is equal to integral q into if. Q is equal to e power minus x, if is e power x dx plus c. So y into e power x is equal to e power 0 is 1. Right, now this can be written as y into e power x is equal to integration of dx is x plus c. Call equation 1. Now boundary values y of 0 is 0, right? That is when x is 0, y is 0. If I substitute here, c should be 0. If I substitute back in equation 1, you get y into e power x is equal to x. Now y is equal to x divided by e power x, right? Therefore y is equal to x into e to the power of minus x. Answer is option B. Right, let's move to the next question. Integrating factor of this. So I can write dy by dx plus y into tan x is equal to sec x, right? Now this is of the form dy by dx plus py is equal to q. Right, p is equal to tan x. I want only the integrating factor. P is equal to tan x. Now if is equal to e per integration of p dx, e per integration of tan x dx. Integration of tan x is log sec x, right? And e per log x is x, that is only sec x. Answer is option B. Right? Question number 20. If I separate the variables, I can write this as dy divided by 1 plus y square is equal to dx divided by 1 plus x square. Right, now if I integrate, integration dy divided by 1 plus y square is equal to integration dx divided by 1 plus x square and plus c. Integration of 1 by 1 plus y square is tan inverse of y. Integration of 1 by 1 plus x square is tan inverse of x, and c can be written as tan inverse of c. Okay, now if I shift on the left side, tan inverse of y minus tan inverse of x is equal to tan inverse of c. Okay, now tan inverse of y minus tan inverse of x is tan inverse of y minus x divided by 1 plus yx is equal to tan inverse of c. Now if I equate y minus x by 1 plus yx, that is xy, is equal to c. Cross multiply, y minus x is equal to c into 1 plus xy. Right, answer is option B. Alright, let's move to the next question. The integrating factor of the differential equation is, I can write this in standard form, dy by dx plus y is equal to 1 by x plus y by x. Dy by dx plus if you shift on the left side and take y common, 1 minus 1 by x into y is equal to 1 by x. This is of the form dy by dx plus py is equal to q. Okay, now p is equal to 1 minus 1 by x. Integrating factor is equal to e per integration of p dx, right? This is e to the power of 1 minus 1 by x dx. Integration of dx is x, integration of 1 by x is log x. Right, now this can be written as e power x into e power minus log x. Isn't it, guys? Now this can also be written as this can also be written as e power x minus log x can be written as log 1 by x. So this is e power x, e power log x is x. So you get e power x upon x. Answer is option B. Question number 22. Y is equal to a e power mx plus b e power minus mx satisfies the following differential equation. Let's call equation 1. There are two a, b and e power mx, no? Okay. Let me check which differential equation will satisfy. Differentiation of e power mx is m e power mx. E power minus mx is equal to minus b m into e power minus mx. If I differentiate once again, d square y by dx square is equal to m square a into e power mx. This minus and minus is plus b m square e to the power of minus mx. Now d square y upon dx square is equal to, I'm going to take m square common, a e power mx plus b e power minus mx. From equation 1, if I substitute, you get d square y by dx square is equal to m square into y is equal to m square into y. If I shift on the left side, d square y by dx square minus m square y is equal to 0. Okay, answer is option C. Question number 23. Solution of the differential equation is cos x into sin by into dx is equal to minus sin x into cos y into dy. Alright, now if you separate the variables, cos x divided by sin x into dx is equal to minus cos y divided by sin by into dy. Alright, now if I integrate, cos by sin is cot, right? Cot x dx is equal to minus integration of cot y dy and plus c. Integration of cot x is log sin x is equal to minus integration of cot y is log sin y, and c can be written as log c. Okay, now if I substitute here, log of sin x plus minus, you shift on the left side, it is plus log of sin y is equal to c can be written as log c. Log x plus log y is log x into y, right? This is log of sin x into sin y is equal to log c. Now if I equate the corresponding values, you will get sin x into sin y is equal to c. Answer is option B. Okay, now the solution of this differential equation is, it's a linear differential equation, right? If I divide by x, if I divide throughout by x, this is of the form dy by dx plus y by x is equal to e power x divided by x. Alright, now this is of the form dy by dx plus p by is equal to q. P is equal to 1 by x and q is equal to e power x divided by x. Integrating factor is e power integration of p dx, e power integration of 1 by x dx. E power integration of 1 by x is log x, e power log x is x only. Alright, now the solution is y into if is equal to integral q into if and then dx plus c. So y into if is x, right, is equal to integral q into if e power x divided by x into x and then dx plus c. This will cancel. Okay, this is x, so x will cancel x. X into y is equal to integration of e power x is e power x and plus c. Okay, there's no option like this. If I divide by x, y is equal to e power x divided by x plus c by x. C is a constant, k is a constant. Answer is option A only. Alright, question number 25. The differential equation of family of curves where A is an arbitrary constant is. Alright, it's a question based on elimination of arbitrary constants. I can write x square plus y square is equal to 2ay, right? This is x square plus y square upon x is upon y is equal to 2a. Now if I differentiating with respect to x, right, now I'll use the quotient rule, u by v. This is v into u dash 2y into dy by dx. This is v into u dash 2x plus 2y into dy by dx. This is v into u dash, right, minus u into v dash minus x square plus y square into v dash is dy by dx by v square, that is y square, and 2a is a constant which is 0. Okay, now if I cross multiply this, cross multiply y square, it will be 0. Multiply the numerator, you get 2xy plus 2y square dy by dx minus x square plus y square into dy by dx is equal to 0. Y square dy by dx is equal to 0. Now what I'll do is I'm going to write this as 2xy plus I'm going to take dy by dx common. Okay, left out is 2y square minus x square minus y square is equal to 0. That is 2xy plus dy by dx. 2y square minus y square is y square minus x square is equal to 0. Now this is, if I shift on the right side, dy, this is 2xy. 2xy is equal to minus of y square minus x square into dy by dx. Now this is 2xy minus of x square minus y square is equal to x square minus y square. Minus of y square minus x square, if you open the bracket you get x square minus y square into dy by dx. Okay, answer is option A only. Alright, Next, let's move to the next question. Question number 26. Family of curves will correspond to differential equation of order. See, I can write this as you call equation 1 order, right? So if I differentiate this, number of arbitrary constants is equal to order of the differential equation, right? There's only one constant, arbitrary constant A. Order should be 1. Even if I solve the normal method, looking at the question only answers 1. Now if I want to solve dy by dx is equal to differentiation of ax is a, right? And differentiation of a cube is 0. I substitute the value of a in equation 1. Y is equal to dy by dx into x plus this is dy by dx the whole cube. Whole cube order is equal to 1. Right, question number 26. 26. Yes, question number 27. The general solution of the equation is, first we'll separate the variables. I can write this as dy by dx is equal to 2x into e power x upon e power y. E power minus y, you shift to denominator, you get e power plus y. If I cross multiply, e power y into dy is equal to 2x into e power x into dx. E power y into dy is equal to 2 times integration of x into e power x dx and then plus c. Integration of e power y is e power y, 2 times, let us use by parts. First function is x, integration of e power x is e power x, minus e power x, differentiation of x is 1 and then dx. E power y is equal to 2 into a bracket, you get x into e power x, integration of e power x is e power x and plus c. E power x square, right? Sorry, so this is e power x square. Right, now if I simplify this, so e power x square is equal to 2x into e power x square and then dx plus c. Right, now I'm going to substitute x square is equal to t. Differentiation of x square is 2x dx is equal to dt. Okay, integration of e power y into dy is equal to integration of e power t. 2x dx is equal to dt plus c. Now integration of e power y is e power y, integration of e power t is e power t and plus c. Right, so this is e to the power of y is equal to e power t is x square and plus c. Okay, answer is option C. E power y is equal to e power x square plus c. Question number 28. The curve for which the slope of the tangent at any point, slope of the tangent dy by dx at any point is equal to ratio of the abscissa to the ordinate, that is x by y. Abscissa is the x coordinate, ordinate is the y coordinate. Dy by dx is x by y. If I cross multiply, I get y into dy is equal to x into dx. Right, now if I integrate, integration of y into dy is equal to integration of x into dx and plus c. Integration of y is y square by 2, integration of x is x square by 2 and plus c. Alright, now if I multiply by 2, if I multiply throughout by 2, you will get y square is equal to x square plus 2c. Y square minus x square is equal to 2c. Alright, this should be hyperbola. This is of the form y square minus x square is equal to a square. Or it can be x square minus y square. I can write this as x square minus y square is equal to minus 2c. C is a constant, minus 2c is also a constant. So this is of the form x square minus y square is equal to k, something like this. Even this is hyperbola, x square minus y square is equal to a square. Alright, it will be rectangular hyperbola. When you have x square minus y square is equal to a square, will be rectangular hyperbola. That is, length of the transfer axis is same as length of the conjugate axis. That is called the rectangular hyperbola. Length of the transfer axis is equal to length of the conjugate axis. Okay, that's called the rectangular hyperbola. Answer is option D only. Question number 29. This is of the form dy by dx minus x into y is equal to e power x square by 2. Right, now this is dy by dx plus py is equal to q. That p is equal to minus x and q is equal to e power x square by 2. Integrating factor is e per integration of p dx, e per integration of minus x dx, which is equal to e power minus x square by 2. Okay, now the solution is y into if is equal to integral q into if, okay, and then dx plus c. Y into if is e power minus x square by 2 is equal to integral q e power x square by 2. If is e power minus x square by 2, okay, and dx plus c. Y into e power minus x square by 2 is equal to e power 0 dx plus c. Powers are added, right? It becomes e power 0. Y into e power minus x square by 2, e power 0 is 1, dx is x and plus c. Now I can write this as y divided by e power x square by 2 is equal to x plus c. If you cross multiply, you will get c only, option C. That is x plus c into e power x square by 2. Right, good question guys. It's a question on linear differential equation. Just bring it to standard form and integrate. Okay, question number 30. The solution of the differential equation is, if I separate the variables 2y minus 1 into dx is equal to 2x plus 3 into dy. Now this can be written as dx divided by 2x plus 3 is equal to dy divided by 2y minus 1. If I integrate, you get dx divided by 2x plus 3 is equal to integration dy divided by 2y minus 1 and plus c. Integration of 1 by x is log x. You will get log of 2x plus 3. Coefficient of x is 2 divided by 2. Again, this is equal to log of 2x minus 1. Coefficient of x is 2 divided by 2. Y is 2 divided by 2 and plus c. Okay, so this can be written as log of 1 upon 2, shift on the left side. You will get log of 2x plus 3 minus log of 2y minus 1 is equal to c. Log m minus log n is log m by n. This can be written as log of 2x plus 3 divided by 2y minus 1 is equal to, cross multiply 2c, you get 2c, right? So 2c is also a constant, so I will write this as log c or log k. I just skip one step guys. Cross multiply 2, you get 2c. 2c is a constant, log k is also a constant. Now if I equate them, you will get 2x plus 3 divided by 2y minus 1 is equal to k. Answer is option C. Right, question number 31. You call equation 1. I'm supposed to find a differential equation. dy by dx is equal to differentiation of cos x is minus sin x, right? And differentiation of sin x is cos x. You call equation 1. If I differentiate once again, d square y by dx square is equal to minus differentiation of sin x is cos x, right? And differentiation of cos x is minus sin x. This will be d square y upon dx square is equal to, take minus common, it will be a cos x plus b sin x. Okay, so d square y upon dx square is equal to minus a cos x plus b sin x is same as y. If I shift to the left side, d square y upon dx square plus y is equal to 0. Answer is option A. Question number 32. See, again it's a question on linear differential equation. This is of the form dy by dx plus py is equal to q. P is equal to 1 and q is equal to e power minus x. Integrating factor is e power integration of p dx, e power integration of dx, which is equal to e power x. Solution is y into if is equal to integral q into if and then dx plus c. Y into if is e power x is equal to integral q. Q is minus x, if is equal to e power x dx and plus c. Y into e power x is equal to, you get e power 0 dx plus c. E power 0 is 1. You get y into e power x is equal to integration of dx is x plus c. Okay, call equation 1. Y of 0 is 0, right? That is when x is equal to 0, y is equal to 0. 0 is equal to 0 plus c, so c is equal to 0. Substitute back in equation 1. You get y into e power x is equal to x. You still don't get the option like this. I can write y is equal to x divided by e power x, right? This means that y is equal to x divided by e power x. That is y is equal to x into e power minus x. Answer is option D. The order and degree of the differential equation is, order will be 3, degree is 2. Answer is option D. Again, the order and degree, order is 2, degree is 1. Okay, the differential equation of family of curves. There's only one constant, right? So you have to differentiate once only. You get 2y into dy by dx. Differentiation of 4ax is 4a. This will cancel 2 times. 1 by 2 into y into dy by dx is equal to a. If I substitute back in equation 1, you will get y square is equal to 4 into a value is half of y into dy by dx into x plus, this is half of y into dy by dx. This will cancel 2 times. You will get y square is equal to 2y x into dy by dx. If you open the bracket, plus 2 will cancel with 2, right? Y square into dy by dx the whole square. Okay, now this can be written as, it should be last option D only, guys. 2x, so the y is common, right? Throughout y is common, I'm going to divide by y. If you divide throughout by y, you get y is equal to 2x into dy by dx plus y into dy by dx the whole square. Right, so this is 2x into dy by dx plus y into dy by dx the whole square, and then minus y, okay, is equal to 0. Is equal to 0 is missing, answer is option D. Let's move to the next question. See, again this is a question on linear differential equation. You can write dy by dx plus py is equal to q. P is equal to tan x and q is equal to sec x. If is equal to e per integration of p dx, which is e per integration of tan x. Okay, integration of tan x is log sec x. E per log x is x, you get sec x. Now solution is y into if is equal to integral q into if and then dx plus c. Y into if is sec x is equal to integral q is sec x. If is equal to sec x dx plus c. Y into sec x is equal to integration of sec square x dx and plus c. That is y into sec x is equal to integration of sec square x is tan x, right? Tan x dx, tan x plus c. Answer is option A. Y into sec x is equal to tan x plus c. Option A only. Right? Question number 37. Again, this is linear differential equation. dy by dx plus py is equal to q. P is equal to 1 by x. P equal to 1 by x and q is equal to sin x. Integrating factor is e per integration of p dx. E per integration of 1 by x dx, which is e power log x. E per log x is x. Solution is y into if is equal to integral q into if and then dx plus c. Y into if is x is equal to integral q. Q is equal to sin x into x dx plus c. On the right side, we'll use by parts. This will be 1, this will be 2. Okay, now x into y is equal to first function is into integral of second function minus integral of second into differentiation of first. So you get x into y is equal to minus x into cos x. Minus and minus is plus, integration of cos x is sin x and plus c. So this is x into y plus x into cos x. It should be first option only. Is equal to sin x plus c. Here if I take x common, you will get y plus cos x is equal to sin x plus c. First option. Okay, now if I separate the variables, e power x plus 1 y divided by y plus 1 into dy is e power x divided by e power x plus 1 dx. Integration of y divided by y plus 1 into dy is equal to integration of e power x divided by e power x plus 1 into dx and plus c. I can write this as y plus 1 minus 1 divided by y plus 1 dy. Do you differentiate denominator, you get numerator, you get x plus 1 and plus c. C can be written as log C. Now if I separate this, y plus 1 divided by y plus 1, right? And then this is dy minus integration of 1 divided by y plus 1 dy is equal to log of C is a constant, K is also a constant. So this is, let's say, log K. Okay, so this is equal to K into e power x plus 1. This will cancel, dy is y. Dy is y, this is minus log of y plus 1 is equal to log of K into e power x plus 1. Y is equal to log of y plus 1 plus log of K into e power x plus 1. Log m plus log n is again log m into n. You will get y is equal to log of K into y plus 1 into e power x plus 1. Right, answer is option C. Alright, question number 39. I can write this as dy by dx dy by dx is equal to e power x into e power minus y plus x square into e power y. Dy by dx is equal to e power minus y, e power x you take common. This is e power minus y, sorry. So I'm going to take e power minus y common. Left out is e power x plus x square. Dy by e power minus y is equal to e power x plus x square. And then dx. Integration of e power y dy is equal to integration of e power x plus x square into dx plus c. Integration of e power y is e power y, e power x, integration of x square is x cubed by 3. And then plus c. E power y minus e power x is equal to x cubed by 3 and plus c. Answer is option B. Right, question number 40. This is the last NCERT exemplar question. This is of the form dy by dx plus py is equal to q. Right, now this p is equal to 2x by 1 plus x square, right? And q is equal to 1 plus x square the whole square. Now this can be written as integrating factor is e power integration of p dx, right? E power integration of 2x by 1 plus x square, right? E to the power of your differentiate denominator, you get numerator log of 1 plus x square. E power log x is x, you get 1 plus x square. Now the solution is y into if is equal to integral q into if and then dx plus c. Y into if is 1 plus x square is equal to q into if, that is 1 plus x square the whole square into if is 1 plus x square and then dx plus c. This will cancel with the square. Okay, then you get y into 1 plus x square is equal to integration of 1 by 1 plus x square is tan inverse of x plus c. Answer is option y into 1 plus x square is equal to c plus tan inverse of x, first option only. Right, so I'm done with all the NCERT exemplar questions, guys. I'm done with all the NCERT exemplar questions. That is indefinite, definite area, and then differential equation, full calculus. Watch my complete videos on this integral calculus. That is NCERT exemplar questions, MCQs on integral calculus. All right, I'll come up with some more videos in my next session, guys. All right, please subscribe my channel. Please subscribe our channel, enable the bell icon so that you get the notifications for all our classes. All right, if you've already subscribed, please share our videos. All right, thank you guys. Thanks for watching. God bless you. In my next video, I'll come up with MCQs of NCERT MCQs on integral calculus. Until then, bye.